Here we have the continuously compounded interest formula. It is given by a of t equals p times e to the power of rt. Example 125 says a total of $1,000 is invested at an annual interest rate of 12%. Find the balance after 3 years if it is compounded biannually, monthly, and continuously. Let's go ahead and start off with biannually, which means twice per year. For parts A and B, we are actually going to be using a different formula than the one that we just saw. It's going to be a of t equals p times 1 plus r over n to the power of n times t. And here we want to evaluate a of 3 because we are plugging in 3 years into our function. Our principal amount is $1,000 and our interest rate is 12%. If we're compounding biannually, that means we're compounding 2 times per year, so my n value is 2, and then the last thing we can plug in is a t value of 3. Now if you take this and throw that into your calculator, you will find that after the 3 years, you will have $1,418.52. Let's move on to part B. I want to evaluate a of 3. And so we're going to use the same formula that we used before. Now the only thing is we are changing the n value to be 12 since there are 12 months in a year. And now if you throw that into your calculator, you should find that there are $1,430.77. after your 3-year period if you're compounding monthly. All right, lastly, let's move on to part C, where we are compounding continuously. Because we are compounding continuously, now we're going to go ahead and use the formula we saw earlier, where we have p times e to the power of rt. Now we're going to be evaluating a of 3. So I'm going to go ahead, my principal value is $1,000. I have Euler's number E, my interest rate is 12%, and we want to find what we're going to be getting after 3 years. Once again, if you throw that into your calculator, you will get $1,433.33 after the 3-year period. Now, hopefully you notice that these amounts of money have gone up as we went through parts A, B, and C. So one thing that should be clear is if everything else remains the same, but you're changing the number of times that you're compounding per year, as the number of times you compound per year increases, the more money you will be receiving after a specific time period.